numbers there, a -2 and a -10. Always carry the sign with the number on the right, because the sign now describing, the sign is like an adjective here. What kind of a 10? A -10. Okay, a -2. So that negative sign can also be a verb, you know, it can tell you subtract, take out. So as a verb is telling you take out, but as an adjective is negative. Okay, so that sign there is serving both purposes. It's as a verb and it's as an adjective. Okay, so you can actually separate the two numbers, and that's what you have. Okay, and then here you have it. -2 subtract 10 is -12, and we know why. Okay, your calculator will give you -12, and to figure it out, to think about it, reason it out.
Take scroll up a while.
Okay. Yeah.
A little higher.
So,
Yeah.
why
Thank
we're not
you.
we're not supposed to add or subtract matrices which are not of like terms. For instance, a 4 by 4 cannot subtract a 5 by 3.
Right, because remember, to add and subtract matrices, you must
It has
add
to
and
be
subtract the corresponding elements.
corresponding. But can we do it? Can we multiply or divide in that with that?
Well, we come into that. We come into the question. So hold that thought, keep that thought. Right, so look at multiplication now, evaluating the following. So just go back, just to review, based on what we did, I think you all should be able to do number 5 and 6. Okay, because
So
5 and 6,
we have that covered, sir.
right, 5 and 6 is just like number 4. Just make your
Yeah.
equation and then you solve for the missing letter. Okay,
Right.
right. So we go into multiplication of matrices. All right, so let's come down to multiplication of matrices. Right, so you have, for example, evaluate the following, and you are not seeing any sign between the matrices. When you don't see any sign between two symbols, automatically is a multiplication.
Right.
So we have one like A, 1A, B, C, and D. So we're going to make examples like them. You have exercise 6, and you have those there, more elaborate. And then you have,
Question.
yes.
Before you proceed, there's not 5, exercise 5. I see you jump from 4 to 6.
Well, in the units, let's check in the units, because I did not choose any.
Yeah.
I did not choose all the questions in the units, because some of them now is like repetition. So if you want to go in the
Okay.
units,
All right
give
then.
it 4 to see if there was an exercise 5. But it's a good observation. Let's check it out. If it's not in the assignment, you can still do it just for
Well,
practice.
yeah, we'll proceed. I just observe it, so I just mention it.
Yeah. So let's take a look at it to see what it's all about. All right. We still have first day, so not rushing. Okay. If certain parts in the assignment we haven't finished yet, we can just leave it as bonus. Right? The whole idea is that I don't want to be rushing this. I want us to create a solid foundation, not just for college algebra 1, but for the future. So take note of those things, you know, because you're going to meet maths. No matter where you go, you're going to meet math, because maths now is the numerical language. And to be a professional, you have to be able to communicate using numbers. So let's see if there's an exercise 5. And if it is not in the assignment, you have some time, try it out. Okay, so that's all 1, 2, 3, 4, and 5, right? That's it. 1, 2, 3, 4, and 5. Exercise 3, operations, multiplication. You have an exercise 4. I copied it. And here you have some notes. Oh, here's an exercise 5. Let's look at it. There's a table that you have to determine whether or not two matrices can be multiplied. I didn't want to put it because although it is valid, you know, when it is possible to multiply or not. Now, the reason why I did not put it is because I have a different way of viewing it than how it is written in the unit.
But we'll do that after, sir.
We can do that after, okay?
Yeah, you can skip that. Let's go. Let's continue where you were.
Right, because it would have given us a little confusion from my
Right,
experience. So
right,
I say,
right.
let me leave it up because I prefer to communicate it how how I see it.
Okay.
Because yes, for addition and subtraction, you can only add and subtract matrices of the same
Oh, yeah.
size. But with multiplication of matrices now is a different ballgame. Now, how it is written in the unit, it is correct. That's one way of looking at it. But as you know, there are different ways of probably looking at the same thing. So I have a way of looking at it now, which is different from what is, and that's what exercise 5 is all about. So I say I will not put it because, and here it is. There's the way that is being expressed. But here's my way now. Extra notes for finding out if you can multiply two matrices. So in the unit, this is what is given. How to determine whether or not two matrices can be multiplied. But now, I designed a way. I've not really seen it anywhere. I looked it up, but probably it's even my invention. But I have to look it up to see somebody else. But that's how I normally communicate to determine whether or not two matrices can be multiplied. We'll come back to it. Okay? And when you multiply two matrices, what your end result will be. Let me ask a question. If you add two matrices of the same size, what your result will be?
Same thing.
Same thing. So if you add a
Yeah.
2 by 2 and a 2 by 2, you expect to get another 2 by 2. If you add a 2 by,
Yes, a square matrix, they call it.
right. If you add a 2 by 3 and a 2 by 3, your final answer will also be a 2 by 3. Okay? 2 by 2, 3 by 3 is a square matrices. If you add a 3 by 3 and a 3 by 3, you expect to get another 3 by 3. But that's not the case with multiplying matrices. Okay? So let us so all this is examples from the notes. So I doesn't ignore the notes example, but I'm giving you our example. Okay? Right. So you have this exercise 4 here. You have an example. I want us to formulate an example. Let's call it A. Let's go in insert equation. The notes up there, but what I will do, I will discuss it now and then we can go back and review it. I want an example just like A, different number.
3 and 6.
3 and 6. So what type of matrix is A?
A 1 by
One by
2.
two.
A 1 by 2.
What's it looking different?
What type of
Because
matrix? What type of matrix is B? Just a minute, keep that thought.
D is a one
2
by
by
one.
1.
B is a what?
One by one.
The 2 by 1.
Oh, two by one,
B
sir.
is a 2
Yes,
by 1.
bro. Two by
Now,
one.
as she says, it's looking different, isn't that so? Keep that thought. What number we can put there? Let's put a negative 3. Let's put an 8.
so when you say B is a 2 by 1.
B is a 2 by
There's
1.
rows,
That
two
second
rows
one there?
and one column.
Oh, oh, I don't know. I was on B, like BB.
Oh, no, the second matrix. The second matrix is a 2 by 1.
Okay,
The first matrix is a 1 by 2, 1 row and 2 columns. And the second
right.
matrix is a 2 by 1, 2 rows and 1 column.
Yes, correct.
Okay. Now, it says evaluate the following. That's how it come in the question. My advice now is to determine. So my advice, when you see multiplying matrix, when you're going to multiply matrices, your initial steps. Why is that? Your initial step, I would encourage you all to do two things. Even though the question does not say to do it, but I would encourage you all to do two things. First, determine if multiplication is possible. And second, determine the size of the product. Because when you multiply, you're going to get a product. When you add, you're going to get a sum, right? When you subtract, you're going to get a difference. When you divide, you're going to get a quotient. And when you multiply, you're going to get a product. How are you going to determine if multiplication is possible?
By checking the rows and the column.
Yeah,
Ah,
make sure they have the same elements.
keep that thought, keep that thought, keep that
So
thought.
I know
Ah,
when they have the same row and column.
right, but that's not how the way I normally communicate.